Welcome to Spring LIB.
In this question, given data is there is a figure given of cart. So first I will draw this figure. So this is a side view of cart having wheel, that is this wheel, and in the question it is saying that there is a slot is made on the floor of cart. So assume that this is a slot at this point. So I had made the location of slot. Now in the question it is saying that there is a pendulum bob is given in the figure, which is connected to roof of cart. So assume that at this point it is connected by string. So now mass of pendulum bob is given, that is small m, and mass of cart is given, that is equal to capital M. So further in the question it is saying that after some time the string of this pendulum bob is breaked, and then after it fell down on the floor, and after severe collision it will land up in the slot. That means the final position of pendulum bob is, that is here. So it is asking that we have to find displacement of cart during this process, and in the question the horizontal distance between pendulum bob and slot is given, that is capital L. So this is the question. Here we have to find the displacement of cart by using the data. So let's start answering this question. So initially their center of mass of system will be written as, that is center of mass at initial condition will be written as, that is equal to small m times of capital L plus capital M times of 0 over small m plus capital M. So simplify it, then I will get the center of mass of system at initial condition. So it will be written as, that is m over m times of L over small m plus capital M. So now in the question further there is a case given, that is the ball is pendulum bob is, that is after string is breaked, the pendulum bob is fell down on the floor, and after several collision it will go inside the slot. So if I consider that center of position in new case will be from consider that this point is I giving name, that is slot is at P point. So the center of mass will be written as, in this new case I will say that will be equal to 0 from point P. So it means when the bob falls in the slot, the center of mass is at distance, that is 0 unit from point P. So point P is where a slot is made. So I can say that now after getting the information I can say that the shift in center of mass will be written as, that is equal to, write the final condition and then initial condition of this center of mass. So final condition is that is after Bob falls in the slot, I can say that final condition is that is 0. So here I will write final condition that is 0 minus, now write the initial condition, so value is that is this, so here write this value, so I can say that MOL divided by small m plus capital M. So simplify it, then I will get the shift value of shift that is equal to minus small m times of capital L divided by small m plus capital M. So here negative will saying that the direction will be that is towards right, because positive sign will show that direction is that is towards left, and negative sign will show that that is direction is towards right. That means the shift in change in center of mass is that is towards right, but you can see in the figure that is there is no external force is acting, so I can say that here center of mass is not changing. I can say that the cart is displaced by at a distance of small m times of L capital M plus small m towards right, because there is no external force in the horizontal direction. So I can say that the center of mass will not change. So that's the reason that is the cart is displaced by distance that is ml divided by m plus m towards right. So this is the answer of given question. Hence I had solved the question completely. Thank you. And one thing you also notice that here in the shift the initial condition and final condition is taken from point P. So I had forget to tell about, so this also include in this solution. Thank you.